So today what we're gonna do, since last time we basically did all the divider chooser methods and went over those, is that we'll focus today on the bidding methods, all right? Now, before we move on, I want you to remember that we looked at all these divider chooser methods, which is one person divides and the other person chooses if it's with two people. If it's with more than two people, then what we can have one person divide, so we can have a lone divisor method. We could have the lone chooser method. That's where a bunch of people divide, and then there's another individual that comes along and chooses a little bit from each pile. Or we could have last diminisher method. That's where I take a bag of goods, we move down the line, each person in line can say, I'll take that, throw something out, or I'll let you keep it. And with all of those, you're guaranteed a fair share so long as the divider can actually divide it into piles. And in all of those, the main disadvantage to these divider chooser methods is that the last person to act, the chooser, is in the better position. So if it's two people, the person who chooses is in the better position. If it's the last diminisher method, the person who's at the end of the line is in the best position. There's also a weird thing about this, that sometimes it's hard to divide into piles. So if I'm the pirate who comes across the treasure chest and I say there's three of us and we need to divide it between three people, and I say, man, there's really no way I can divide this between three people in any fair way. I can't get to 33.3% in my view. So we want to try to take away those two disadvantages. So the first thing we're going to do is we're going to try to take away this disadvantage of the last party is in the best position. And this brings us to the bidding methods. Now, we're going to look at two different bidding methods. One is in section 5.2. That's called the adjusted winning procedure. And the other in 5.3 is a sealed bids method, also called the Nassar inheritance procedure. But what this adjusted winning procedure will do is it will take away the positional advantage in divider chooser method. So here's how the adjusted winning procedure works. The adjusted winning procedure is that there's a number of issues or a number of piles of goods. And let's start with just two parties. So there's two individuals who have to split up a bunch of piles of goods. So instead of picking piles, what we do is we give each individual 100 points to spend. All right? So they have to spend their 100 points. And what they're going to do is they're going to say, I spend 20 points on this issue or this pile. I spend 30 points on this issue, this pile. I want to spend 40 points on this issue, this pile. And by doing so, they're putting a bid, in some sense, on each item or on each pile. Does that make sense? Now, initially what we do, on step one, we pretend that the highest bid for each item wins the item. So if I bid 30 points and the other person bid 20 points, I win the item. And we do that for all the items. Now, if we would stop there, it wouldn't be fair. Because sometimes I might walk away with too many points. And so after we say, well, let's try to give the highest bid to the person, or the highest bid on each item to the person who made it, we count how many points are used and how many points are unused. And then we try to transfer items in order to balance out the points the best we can. All right. Ideally, we want the points to be equal at the very end. Sometimes that's not possible, so you get as close to equal as you can. But that's it. So basically you say, who gets the highest bid? Now count up the points and transfer items back and forth between individuals until the points more or less equal out. Is that right? So this is called the adjusted winning procedure. The adjusted part is the transferring items. So that's why it's called adjusted, right? We're adjusting who wins so that we balance out the points. Okay. Let's do it in an example. Sorry, I'm going to once again try to put this on the overhead and just write in the table. So we have 2 people and 6 items or 6 piles of goods, or however you want to say this. All right. Let's see if I can make that a little bit bigger. Can we read that? Good. So what we've done is we have these 6 items, 6 piles of goods, 6 issues, whatever they are. And here's how person A spent their points. They spent 50 on pile number 1, 15 on pile number 2, 15 on pile number 3, 15 on pile number 4, 5 on pile number 5, and 0 on pile number 6. Person B spent 25 on pile number 1, 10 on pile number 2, 10 on pile number 3, 20 on pile number 4, 20 on pile number 5, and 15 on pile number 6. And if we add those all up, you get 100 points spent by each person. So it's pretty clear that in pile number 1, person A has the higher bid. They spent 50 points, where person B spent 25. Same thing with pile number 2. A spent more points. Same thing with pile number 3. A spent more points. On piles numbers 4, 5, and 6, B spent more points. All right. Now, after we've done this, I'm going to zoom a little bit, sorry. A little wider. That's better. All right, so after we've done this, we're gonna count how many points A has spent on their winning items. So if we give these items to A has won 50 plus 15 plus 15. So A right now has won 80 points worth of items. And the same thing with B, we're gonna count up the items that B has won. Right now, if we just give the highest bid, 20 plus 20 plus 15, we just give the items to B, which B got the highest bid for, B receives 55 points. All right. Now we want to make that more balanced. So notice that the difference between the points that A won and what B won is 25 points. Everybody see that? And so I look at the items and I say, well, is there an item which I could exchange, I could take away from A and give to B so that 25 points is exchanged? And in this case, there's actually 2 items that would do that. If you take away 15 points from A and give 10 points to B, that's a 25-point swing. Does that make sense? This is the adjusting part of the adjusted winning procedure. Now, you could have also done that with item number 2 as well. But notice if you tried to do that with item number 1, that's a 75-point swing. That's way too much. Okay. So we look to see if there's either 1 or 2 items that will add up to this disparity in points. And sure enough, item 3 does that. So what I'm going to do is I'm going to give item 3 to B along with everything else they won. And then items numbers 1 and 2, we're going to give to A. So before the adjustment, A had 80, B had 55. Now, after the adjustment, I want you to know notice how many A has. A won these first two items. A thought item number 1 was worth 50, item number 2 is worth 15. So A walks away with 65 of their spent points out of 100. And B walks away with 10 plus 20 plus 20 plus 15. And that's also 65 points out of their 100. Everybody get that? So now both individuals walk away with 65 points. Now this is out of 100, so you can also say A walks away with 65% of the goods, and B walks away with 65% of the goods. Since there are two people, one half is 50%. Both people walk away, both walk away satisfied. They both walk away with more than their fair share, don't they? So the adjusted winning procedure has the advantage of both of these individuals walk away with more than their fair share, and there's no positional advantage because each person bids anonymously. And then after the bids are done, then we figure all this stuff out. Okay? Does that make sense? So it's advantageous compared to the divider chooser method. I want you to try that same process on your own in example number 2. So let's go through this. So the first step should always be pretty easy. Highest bid is just the highest number. So on either pile number one, issue number one, B is higher. On issue number two, pile number two, whatever it is, A is higher. On three, B is higher. On four, B is higher. On five, A is higher. On six, A is higher. On seven, B is higher. Now, at this point, before the adjustment, A has, well, let's look, 13 plus 19 plus 18. So A has 50 points. And B has, well, let's see what B has. 22 plus 9 plus 25 plus 10. When you add those up, that's a total of 50 points. No, I'm sorry, 66 points. Read that wrong line. Okay, that's a difference of 16 points. Okay, so I go and I look up and I say, is there one or two items that I could exchange, take away from B because B is higher, and give to A because A is lower, that would exchange 16 points. And it turns out issue number 3 is a perfect issue for that. Or pile number 3 is perfect. 9 and 7 add up to 16. I can take it away from B and give it to A. And that's a difference of 16, right? One side goes down by 9, the other side goes up by 7. Every other item is going to stay the same. Okay. And now, after I've done that adjustment, copy and paste that. If you look at how many points A and B now have, so A would have walked away with 7, or 13 plus 7 plus 19 plus 18. A now has 57 points of what they spent. And if you look at B, 22 plus 25 plus 10, they also have 57 points. So both A and B walk away with more than their fair share. And in fact, they walk away with the exact same percentage of points spent, 57%. Does that make sense? That easy process? Okay. Because we started out assuming that the highest bid was going to win, when you do your adjustment, you should always be above 50, as long as you have piles and issues that are, not going to take up huge majorities of your points. All right, whoops. Now, you can do this same process with 3 people as well. It just takes a little bit more, because you're trying to balance 3 people's point spending, right? And because there's 3 people, you hope everybody walks away spending 33.3 points or more. Does that make sense? But it might take a little bit more cleverness to do the balancing act. So let's do this one together. I can duplicate the table. Well, I can do this. I can just write it in here. Right? I don't want to do that because I want to count the points. I like having to adjust all the margins every time, but it's the way it goes. Okay, so let's go ahead. Highest bid wins. On this first pile of goods, highest bid is person A. On the second pile of goods, it looks like person B is the highest. On the third pile of goods, it looks like person C is the highest. On the fourth, it looks like person B. On the fifth, it looks like person C. On the sixth, it looks like person A. And on the seventh, it looks like person A. So A won 3 items, B won 2 items, C won 2 items, is what I'm saying. Before the adjustment, it looks like A has 22 plus 24 plus 10. That's 56 points. B has, looks like 17 plus 24. That's 41 points. And then C has, looks like 12 plus 21. 33 points. Okay. Now, because there's only 7 items, it's probably going to be really hard to balance out perfectly. But we can get a lot closer than this. Does that make sense? So in this case, because there's only a few items, a few piles of goods, it's going to be hard to balance out perfectly. The more piles, the easier it's going to be to balance, all right? Because you can shift things around more. Okay. But what you'll notice is that A has a lot more than B, and B has a lot more than C. So we like to boost C's points, and we'd like to lower A's points to get somewhere in the 40s. Does that make sense? Boost C to somewhere in the 40s and lower A to somewhere in the 40s. Notice this seventh item. This seventh item will take 10 points away from A and give 9 points to C if I give it to C. So if I give item number 7 to C, that's going to be an exchange of 19 points. Now that's not perfect because A and C were 22 points different or 23 points different, but it still gets me closer. Is that all right? So let's do that. And keep everything else the same. If we do that and keep everything else the same, after the adjustment, A will decrease by 10, so it'll have 46 points. B will stay the same because nothing was taken away or added for B. And then C will get an additional 9. 33 plus 9 is 42. Now again, we don't perfectly balance the points here, but that's all right. Everybody walks away with close to the same amount of points and with more than their fair share as they see it. Remember, 33.3% is fair share. A got 46%, B got 41%, and C got 42%. So all of them think they walked away with more than their fair share. Does that make sense? And so you can do this procedure with more and more individuals, but when you get more and more individuals, you'll probably want to have split into lots and lots of different piles to give yourself the ability to give some piles, exchange piles on the adjustment. Does that make sense? Like if there are 30 piles, it'd probably be easy to adjust to make A, B, and C all, perfectly even. But with 7 piles, it's sometimes hard to adjust. All right. Any questions about the procedure in general? Now, the ones that are on the homework, I think all work out, where you can balance them like perfectly. Same thing with the test. I believe the test you can balance perfectly on the adjusted winning procedure. Now, obviously there's some big advantages here. The two that I've been harping on are the 2 bullet points here. People most often walk away with more than their fair share. Like every individual walks away with more than their fair share. And this adjusted winning procedure takes out any positional advantage that the divider chooser methods would have put in. One other really nice part about the adjusted winning procedure is that you don't have to have a pirate treasure chest to do this. The things you're arguing about don't even have to be monetary. Imagine two companies merge together. There might be a lot of things we have to decide if two companies merge together. Let's say my company and somebody else's company merge together. Well, one of the issues that we're gonna have to resolve is what name does the new company go by? Does it go by my company's name or this other guy's company's name? Another issue is gonna be like, who's gonna be in charge? Am I gonna be the CEO or is the CEO of the other company gonna be in charge? Right? Another issue might be where we're located. Notice none of those are really monetary issues, but if we list them all down, we could give a number of points to how much do you care about this? If I cared a lot about the name of the company, but I didn't care so much about where we're located, well, I could give more points to the name and less points to the location. Does that make sense? So this procedure works even when we're not talking about dividing out physical goods. All right. Now, I want to highlight an issue that can happen. That's the main drawback to the adjusted weighting procedure. All right. And it's highlighted here in example 4. Let's assume we're back in the scenario where two people are bidding on issues or piles of goods. I want you to think about how this would go. Issue number 1 or pile of goods number 1 goes to B with the highest bid. A will get issue 2, issue 3, and B will get issue 4. Now notice that before the adjustments, A has only 23 plus 18, which is 41 points. B has 62 plus 10, which is 72 points. That's a difference of 31. What's going to happen if I give, I don't know what's going on here. Oh, shit. I'm sorry. There you go. What's gonna happen if I let A own that issue or own that pile of goods and all three of these piles, and then just let B have the first? Well, guess how many points A is gonna have? After that adjustment, A only has 44 points still. B has 62. So that's not that doesn't give A the fair share, right? A would need 50%, half of the goods, to get a fair share. So if I adjust that way, it's not gonna give A half the points. If, however, I reverse it, I say, well, let's try to put A getting pile 1 and B getting all the other piles. Well, then A has 56 points in that case. But if you look at B, B would only have 38 points. So B doesn't get their fair share, right? And what we see here is that because so many points were spent by both people on issue 1, or pile number 1, there's no way to do an adjustment. There's no way to do an adjustment and for A and B to walk out with what they think is a fair share. All right? And that's because A and B thought so highly of whatever is in pile number 1. And this is the biggest flaw of the adjusted winning procedure. This often can happen if you split your piles of goods into only, 3 or 4 piles of goods. Then a lot of times you don't walk away with 50%. But the key point here is that one pile takes up more than 50% for everybody who's bidding on it. So for the adjusted winning procedure, there's 2 kind of disadvantages. One we talked about earlier, sometimes it's hard to decide how to reallocate. When we had the A, B, C example. So sometimes it's hard to do. Not impossible, just hard. But the real disadvantage is that if we have one really big item that everyone puts a lot of emphasis on, then not everybody can get a fair share with the adjusted winning procedure. That was what we did in this last example. There's no distribution of those piles that'll give A and B both at least 50%. And the reason is there's that one big item. Okay. It's like somebody dies and their house is basically all of their money and stuff is tied up into their house. And so the house is the big, huge thing that's worth everything. And everything else comparatively is worth a lot less. Okay. that work? All right. So to avoid this problem, we're going to look at another technique, which is a bidding method technique as well. Now, this is only going to work with things you can put monetary values on, all right? It's called the sealed bids method, all right? Now, this method is going to allow us to handle big items. And the way it handles big items is we supplement the system with money, with cash. So instead of giving everybody points, we're going to bid with cash this time. And then if I get too much, then what I have to do is I have to sort of pay back in cash to the other individuals in the system. Does that make sense? This sealed bids method is also called the Naster inheritance procedure or the Naster inheritance method because it comes up in inheritance ideas. And I don't know if Naster was the person who originated the idea or just the person it's named after, but that's what it is. So here's the scenario. We have multiple parties, think of inheritors and tangible assets. Or maybe multiple pirates and you're splitting up the treasure chest. Each person puts a money amount bid on every single item. And the highest bid, the highest money amount wins the item. If there's ever a tie, you just settle it by like a coin flip or something like that. Now here's where we get the fair share on. Each party is going to settle the difference between what they think the total amount of goods is worth and what they think the value that they got out is worth. When people do this, there'll probably be a little bit of money left over. And so that leftover money is going to get split up evenly. That third bullet point is the hardest part for people. It's how you settle the difference between their portion of the goods and the values that the goods that they receive. But I'll go through it using some tables and hopefully that makes sense. All right. So let's imagine that there are 3 siblings who are inheriting a house, a car, and a bunch of trinkets inside the house from a deceased mother. Okay. By the way, that's me and my siblings. So that's where I got the names. All right. So here's the 3 items that we can bid on. I could bid on a house, a car, and trinkets. And we have each person say how much they think that's worth in monetary amounts. So Matt bids the most on the house. He bid 120,000 on the house. Jordan and Rachel bid less. Rachel bid the most on the car. She bid 18,000 on the car. And Jordan bid less. And then Rachel bid the most on the trinkets too. She bid 5,000 and Jordan bid less. Those are the name of my siblings. So if I say me instead of Jordan, that's why. Okay. So it's not, I just put my siblings' names in there. My mom's fine and good health, so don't have to worry about that though either. So. All right. Now I hope it's obvious who wins the items. So Matt wins the house. Rachel wins the car and the trinkets. So let me write that. Matt wins house. Rachel wins car and trinkets. Now I want you to understand that Matt, he got the big item, right? He got the 120,000. Everybody agreed that that was the most valuable item here. So if we just stopped here, obviously Jordan would get screwed, get nothing. And Matt would have walked away with the biggest item. That wouldn't be very fair. So here's how we deal with this. If you look at Matt's total bid, if you take 120,000 plus 15,000 plus 3,000, Matt bid $138,000 total. Jordan, I bid less. I bid 126,000 total. Rachel happened to also bid 138,000. Now that's their total bid. But because there are three people, how much should Matt walk away with in his own mind to get a fair share? Well, he should walk away with a third of that number. Does that make sense? Since there's three people, his portion should be a third of 138,000, which is 46,000. That's the hardest part for people to understand. Everybody get that? 46,000. Since Jordan, bid 126,000, I should also walk away with a third. So I just divide that number by 3. I think I should walk away with 42,000. And similarly, Rachel, if you take 138,000 divided by 3, once again, you get 46,000. Okay. Now, when I say difference, I mean the difference in the goods received versus the amount of their portion. Okay. Matt won the house, right? So he already received 120,000. But his portion was only 46,000. So the difference is 120,000 minus 46,000. Which is 74,000. Let me write that on one line. I'll try to. Is that okay, everybody? So Matt's difference is 74,000. Jordan, me, I received nothing. There's nothing I won. But I should have been owed 42,000. So the difference between what I got and what I should have got in my own mind is 42,000. Does that make sense? Rachel, well, she got 2 items. And together those 2 items are worth, it looks like 23,000 according to Rachel. 18 plus 5. She believes she's owed 46,000. So the difference between what she got and what she is owed is 23,000. Okay. So here's the deal. Matt got more than what he owed, right? Therefore, while Matt wins the house, he must pay $74,000. Everybody okay with that? Into a pot somewhere. Rachel wins the car and the trinkets. Those didn't add up to what she was owed, right? So she should get paid back. She should get out 23,000. Jordan, me, wins no items, but gets paid $42,000. Does that make sense? So because Matt got more than what his portion is, he's got to pay an extra. Because Jordan and Rachel got less than what their portion is, they get out some of the extra money that Matt paid in. All right. So Matt's gonna have to pay 74,000. The 23,000 and the 42,000 are gonna come out of that. Now here's the interesting part. Think of what's called in the pot. Matt paid in 74,000. Jordan and Rachel should take out 23,000. Jordan should take out 42,000. That means there's 9,000 remaining in the pot. After all that exchange is done. So at this stage, everybody has what they believe is their fair share monetarily. Everybody has their fair share, and we have 9,000 left in the pot. So what we do is we just split that evenly between the three individuals. So each individual gets $3,000 from the pot above, these numbers. So everybody in their own mind walks away with their fair share plus an extra $3,000. Does that make sense? So that's how it goes. That's how this adjusted winning procedure goes. Everybody ends up with their fair share and then an equal money amount from the pot. Because we gave each item to the highest bid, that actually guarantees we're going to have money in the pot left over at the end. Okay, since each person who got the item is the one who bid the most, it guarantees money in the end. Does that work? Oh, so I already said those things. Oh, that's another one. Let me do this one. This is example 3. I'm skipping example 2. Let's do the Jack and Diane example. We'll do one more example of this sealed bids method. Again, master inheritance procedure is another word for it. So I'll skip example 2 and go right to example 3. Is okay? All right, we have 2 individuals, Jack and Diane. And let's assume they found some treasure, they found piles of goods, whatever. And they split it up into 5 piles. So let's see what Jack is going to get. Jack is the highest bid on pile 2, on pile 4, and on pile 5. So he's going to get those piles. Diane is the highest bid on pile 1, pile 3, and that's it. Okay. Now, obviously, this one doesn't have a table, but we can do the same exact understanding without having all those things to fill in the table. You guys know what I mean by that? So let's check out the total portion for Jack. So the total bid for Jack, 250 plus 215 plus 134 plus 417 plus 118. Total bid for Jack is $1,134. By the way, his portion, which is a half, everybody understand why it's a half? Because we're splitting it between two people. His portion should be half of that, so it should be $567. Everyone get that? Now, I'm gonna kind of complete Jack's part of this before I move on to Diane's. Is that all right? So, because Jack got pile 2, pile 4, and pile 5, Jack got 215 plus 417 plus 118. If you add those up, that's worth 750 to Jack. So what's Jack need to do? Well, we need to look at the difference between what Jack got, which is the $750 worth of stuff in the piles, compared to his portion, which is 567. So it's $183. Now notice that he got more than his portion, right? So Jack needs to pay in $183. Everybody understand what I did there? So I look at his total bid, and then I look at his portion, which because there's two people is half of that. And I compare it to what he got already. He got more than he bid than his portion. Therefore, he needs to pay an extra. All right, let's go for Diane. So total bid for Diane, that's gonna be the sum of those numbers, right? So we're just gonna add those numbers up, 320 plus 208 plus 156 plus 385 plus 115. I got 1184 for Diane as the total bid. Her portion, again, that's a half. Is just take half of that. So divide that by 2. Her portion is $592. Everybody see where I'm getting her portion from? Just half of the 1184, half of her bid. This 567 came from half of Jack's bid. Now to Diane, she got pile 1 and pile 3. So they are worth 320 plus 156 together. That's $476. We get that? So to Diane, those 2 piles that she got are worth $476 to Diane. So the difference is, well, 476 compared to 592. Take 592 minus 476. That's $116. Now, if you notice, she got less than her portion of goods. That means that $116 needs to be coming back to her. Does that make sense? So Diane gets paid $116. Does that make sense? Now, at this stage, if just this happened, everybody would have their fair share exactly. Okay? But we're going to account for what's in the pot. And the way we account for what's in the pot is we just say, well, what is in the pot? Since Jack paid in 183 and Diane took out 116, there is $67 left in the pot. And if I divide that among 2 people, each person is going to get an extra $33.50 from the pot. Does that make sense? I like writing it up there on the board because or writing out there on it's just easier to see, and plus it's using those tables. That way I don't have to draw out all the tables on the board. All right, that's what you're gonna have to do in the homework. You're gonna have to take a table like this and just go through the entire procedure and say who gets what items, who pays in what amounts, who gets back what amounts, and then what's in the pot left over. You're right with that? I'm recording this, so I'll try to post it on video and all that kind of good stuff too. So if you have to reference back, you can reference back to the videos. Any questions about this NASTR inheritance procedure? Sealed bids method is another name for it. Now, let me just go through advantages and disadvantages of this. The advantages are that it's very equitable. Everybody gets their fair share plus extra money from the pot. and there's no positional advantage. Okay, so it's very equitable in that sense. The two disadvantages, one of them is sort of unique to this method. That's the first bullet point. The unique disadvantage to this method is that you have to have cash to make it work. All right. If in our example, Matt did not have $74,000 lying around, and nobody would give Matt a $74,000 loan to go out and get the house, all of a sudden this breaks down. Does that make sense? So you need to have cash to make it work. Otherwise, the process breaks down. Okay, or you need to have access to cash to make it work. And there's this other bullet point, and that this other bullet point is really not unique to this method. But there's no item can be priceless. If, for instance, Matt, Jordan, Rachel were also bidding on who gets to take care of a foster kid who's in the house when our mom died, you'd say, man, that's really weird to be bidding money amounts on a foster kid, right? That would be kind of in the same boat as being priceless. There are some things you just don't want to put a cash bet on. You know, who controls, or if a child lives with their mom or their dad. Let's say two parents are splitting up assets. And so you say, well, does the child live with the mom or the dad? That's not something you want to probably put a monetary bid on. That's kind of weird to do. So that's, no item can be priceless. Although that same bullet point disadvantage can be said for a lot of the other methods too that we've dealt with. You don't want to have priceless items in your other methods either. All right. Any questions over the bidding methods here? Make sense? All right, well, we'll stop there. Don't forget, this 5051 homework is due this Friday. The 5253 homework, that'll be due next Friday, along with this apportionment stuff. Okay, we'll go over the apportionment stuff next week. All right, other than that, I'll see you next time.